So we studied polymethyl methacrylate, which is included in our syllabus. That is addition polymer. Okay. So under addition polymerization, we studied characteristics of addition polymerization with respect to preparation of polyethylene from ethylene. Okay. And another type of preparation of plastics or rubber kind of polymers is condensation polymerization. Okay. So under condensation polymerization, we took typical example which you have already studied, that is synthesis of nylon 66. And then we understood what are the various characteristics of condensation polymerization and obviously condensation polymers. Okay. So this is the way you should do it. You don't mug it up. You should know example of each kind of polymerization. Okay. And just looking at the example is what reaction example. How ethylene is converted to polyethylene. Just looking at the reaction, you can state several points. Okay. And just looking at the reaction, for nylon 66 or you another polymer which we have studied is Kevlar, which is included in the syllabus. So if you know the reaction of Kevlar, you can write several points under condensation polymerization. That's all. Okay. So that we studied last time, and then we are at the another module, green chemistry, where you need to have lot of organic chemistry knowledge. Okay. So last time we understood what is green chemistry. So green chemistry basically it is clean chemistry, pollution-free chemistry, less hazardous chemistry, sustainable chemistry. Okay. So this is emerging approach. Already we have adopted several products under green chemistry. Okay. So present chemistry is not environmental benign or suitable to environment, that we studied last time. So present chemistry, or I will first write one reaction skeleton, which general reaction skeleton. With the help of this skeleton, we prepare several organic compounds, which are actually finished product, which we use in our daily life. Okay, and that structure you know well. Okay, so so that structure includes. Okay, we have starting compound, we call it as a precursor, okay, or we can say a reactant. This is the first part. Okay. Then we add other chemical, we call it as a reagent. Okay. Then there is arrow, forward arrow, okay, which states us reaction conditions. Means we may apply heating or maybe cooling, under pressure or catalyst and or catalyst. Okay. So these are reaction conditions. We also use solvents. Okay. And what we have is product. Product, or I could say major product or desirable product, target product. But unfortunately, we also have another entity called as a byproduct. This is what the common structure of any organic chemical reaction. Okay, you must be knowing this. Reactant plus reagent after heating, maybe cooling or under pressure in presence of catalyst may or may not be, and solvent. These are the reaction conditions. And finally, we get desired product or major product and byproduct. Okay, so you know well this skeleton. You have studied lot of organic chemical reactions. So what I discussed last time, this last lecture, was about this product. So this product can be a plastic. This product can be rubber. This product can be medicine, right? Drug, medicine, antibiotic, vitamins, whatever. This product can be perfume. Okay. This product may be food product. This product may be pesticide, insecticide. So all these products which we use in our daily life, this or that way, directly or indirectly, these products are being prepared by this skeleton. Okay, and these products are organic products, and these products are prepared from the reactant, and that reactant and even sometimes reagent both have one and same origin. That origin is, you must be knowing, we have discussed last time, that origin is petrochemicals or petroleum product. Okay, petroleum products. So you know about petroleum oil or crude oil that is there underneath the earth crust. We take it out from oil well and we send it to refinery where it is subjected to fractional distillation, where we get various fractions, right from heavy oil, then diesel, kerosene, petrol, naphtha, so on and so forth, petroleum ether. Okay, so after fractional distillation, we get various liquid products. Those we use directly. Okay, but naphtha part, naphtha part of this petroleum oil is actually a source of various hydrocarbons, and that is used as a reactant. Okay, naphtha. You might have heard about this. Okay, it consists of several hydrocarbons. Say, for example, I could say benzene, toluene, xylene, maybe aliphatic hydrocarbons, octane, hexane, uh, several hydrocarbons. So this naphtha is source of these hydrocarbons. We commonly call them as a petrochemicals, and they are actually reactant or starting compound or sometimes reagent also to manufacture the several products which we enjoy in our daily life. I just listed out various products like plastics, rubber, medicines, food products, pesticide, insecticide. These all products, okay, which we utilize in our daily life, they are prepared from petroleum products, say naphtha, which contains various hydrocarbons. So we perform basically chemical reactions and we utilize product. Okay, we prepare product and we utilize for our daily life. Now, where is the problem? Where do this green chemistry comes into picture? So at present, we utilize these petroleum products, and these petroleum products have two major drawbacks. Okay, so first drawback is what? These products are hazardous. These products are creating, or these products are polluting. Okay, you know well. So presently, we experience uh, several environmental issues, so including global warming, and the consequence of global warming is irregular seasons, overwhelming, droughts, flooding, etc., etc. Okay, so these are what environmental impact. So these are supposed to be due to the vast use of petroleum product. Okay, so petrol, diesel that we burn in our vehicle, that is one source, but another major source is this only, chemical factories, where these products, finished products, it actually they are, I mean they are compulsory for us. We cannot live without them. Okay, so these products are being produced from petroleum or petrochemicals only, and these are hazardous. These are hazardous or polluting. This is one thing. Okay. Another thing is they are depleting in nature. Depleting in nature means they one day they will be finished. Limited, we have a limited amount of this petroleum oil and consequently the petroleum products. So these are two drawbacks. They are hazardous, creating pollution. One thing. Another thing is they are depleting in nature. So one day they will be exhausted. But we need products, okay, for our daily life. So we should have uh, a proper option, and that is suggested by this green chemistry. You understand? So here green chemistry comes into picture. So how it is defined? So green chemistry also called as a sustainable chemistry. Green chemistry, also called as sustainable chemistry, is an area of chemistry and chemical engineering focused on designing, you see, designing of products and processes that minimize the use and generation of hazardous substances. Okay, that's it. So we have to modify these present routes, chemical synthesis routes, which are utilizing hazardous chemical. Reactant may be hazardous, reagent may be hazardous, solvent or catalyst may be hazardous, byproduct may be hazardous. Sometimes product is also hazardous. Okay, so these are present scenario. So green chemistry does not allow this. Okay, because it is harmful to all of us in the sense workers which are working in the industry, people which are staying nearby the industry, and also harmful to the consumer. We all consumers. Okay, and finally, these products are products, maybe byproducts or some other component of the reaction is harmful to our nature. Okay, so that is what green chemistry says. So we should not use such routes which are utilizing hazardous chemicals. Okay, so basically we have to modify the present chemical routes, and we should have a green chemical route, green route, okay, which allows us to have sustainable product, and on the same time non-hazardous, okay, no pollution to us and to the nature. Okay? That is what the goal of green chemistry. Now, so this is what we studied last time. Green chemistry focused on technological approaches for preventing pollution and reducing consumption of non-renewable sources. Okay, so preventing pollution, okay, hazardous nature, etc., to us and to nature, and reducing consumption of non-renewable resources. Non-renewable म्हणजे काय? ते परत परत रिन्यू होऊ शकतात. Now you know renewable sources. Okay, renewable sources of energy, like say wind power, right? Hydro energy. These are renewable sources. But petroleum based is our petroleum products. They are what, non-renewable. Okay, once we utilize them, they are exhausted, and one day all petroleum oil will be exhausted. So we should have a sustainable chemistry to have a to have all products for long time, for next generations also. So, so pollution control and non-renewable, I mean reducing non-renewable resources. These are the two major goals. So, 12 principles are set up by green chemistry. So we have to follow these principles while setting up new chemical synthesis. So first is waste prevention. We will discuss these 12 principles in detail while studying this module. Okay, we are just taking overview. Waste prevention, then atom economy, less hazardous chemical synthesis, designing of safer chemical products. Now, if you look at these 4 points, you will understand what is the present problem and how to resolve it by adopting green chemistry. Okay. We have to prevent waste, we have to enhance atom economy, we have to utilize chemical synthesis where hazardous chemicals are not used, and designing safer chemical products, talking about products. Okay, then safer solvent reaction condition, solvents should be safe. Designing for energy efficiency, okay, less energy input. Okay, Then use of renewable feedstock means natural compounds, okay, for the preparation of same products, renewable, okay, and not depleting. Then reduced derivatives. This is something in between the chemical reaction. Some derivatives are produced, so we should avoid those avoid these derivatives to make process energy efficient and also to avoid waste. Then catalysis, use of catalysis. This is again energy efficiency. Then designing for degradation. Okay, now if I can give one example: plastic. Present plastic, polyethylene, polypropylene is non-degradable. We know what amount of pains we are taking. Okay, for degradation of plastic. Okay, so designing for degradation. Product should be easily degradable. It should not remain in nature. So that is another aspect, 10th principle. Then real-time analysis for pollution prevention. It is industrial part actually, real-time analysis and inherently safer chemistry for accident prevention. Okay, avoiding use of explosives and all. So these are 12 principles we should follow or any chemical industry must follow to manufacture any product. So that we studied last time. Now we will concentrate on principle number 2 as far as prerequisite is concerned. Atom economy. So waste prevention we will see in detail later on. So we will be concentrating on atom economy. Okay. So what atom economy says? Synthesis of product should be designed in such a way that all the reactants used should be converted into desired product in maximum extent. Okay. So meaning of this statement is we should have chemical synthesis route. Whatever chemical reaction we write, that reaction actually we perform in industry and we get product. So what atom economy principle says? So final product should contain all the atoms which are present in the reactant. रिएक्टंट मध्ये जे काही आयटम्स आहेत ते सगळे सगळे मेजर प्रोडक्ट मध्ये जायला पाहिजे. ओके, अँड नॉट इन द बाय प्रोडक्ट. सो रिडक्शन ऑफ बाय प्रोडक्ट, रिडक्शन ऑफ वेस्ट. Okay, so that is what the meaning of this statement. Okay, all the reactants used should be converted into desired product in maximum extent and not byproduct. So many organic reactions release undesired products along with useful products during the reaction that you have already know. Okay, so there is always byproduct in most of the chemical reactions. So atom economy suggests we should utilize such chemical synthetic route where less amount of byproduct is produced. Okay, this is what the aim of this principle. So such undesired products causes harm to environment. Okay, it is not just a reaction efficiency that is reduced. If byproduct is more, reaction efficiency is reduced. Okay, on the same time that those byproducts we just release out in what atmosphere, or we just dump it on land or in river, etc., etc. So it creates what environmental issues. So atom economy principle is very important. So what green chemistry suggests? So it suggests to design the chemical reactions in such a way that most of the starting material, okay, if possible 100%, all whole starting material. But if not possible, then most most of the starting material is converted into desired product, okay, and not byproduct, and that is known as atom economy. Atoms जे आहेत reactant ते कसे इकॉनॉमिकली वापरले गेले पाहिजे. Okay, they should be converted into desirable product. If they are not converted into desirable product, then byproduct will be produced. That we don't want, because byproduct will create waste. Okay, and that is again creating pollution. Okay, so this is what atom economy principle. So here we will take interesting example to understand atom economy. So before that, I should tell you what is the formula for atom economy calculation. So percentage atom economy काढायची कशी, तुम्ही आता रिएक्शन भरपूर शिकला असता. So how to calculate atom economy? So that is the formula is already there. Molecular weight of the product. Product means desirable product, main product, not byproduct. It is at a numerator divided by total molecular weight of reactant. Now here we should consider all reactant. That is what total. But at the numerator we have molecular weight of only product, not byproduct. Okay? So molecular weight of product upon total molecular weight of all reactants into 100. That is what a percentage atom economy. Okay. So it should be maximum. That synthetic route we should adopt. Okay. Now we will study this atom economy principle with respect to the preparation of malic anhydride. This is one chemical or industrially important chemical which is utilized for the manufacturing of several medicines, drugs, dyes and pesticides. Okay. So this is important chemical. So let us see the synthesis of this compound from three different chemical synthetic routes, and then we will decide which synthetic route is most efficient. Okay, so that synthetic route will be efficient where atom economic is maximum. Percentage atom economic calculate केल्यानंतर जिथे जी maximum असेल तो route best route आहे. Okay, and that will be utilized in industry for manufacturing of maleic anhydride. Other routes will be discarded. Okay, so maleic anhydride can be prepared by the following methods. First, oxidation of benzene. This is the first route. Okay. Then oxidation of butene, oxidation of butane. So these are the three possibilities, three possible hydrocarbons. So these are actually petrochemicals, okay, which are present in petroleum oil. So these petrochemical products we utilize for the synthesis of the finished product, which we enjoy in our daily life. Okay, so in this case, maleic anhydride. So maleic anhydride can be prepared from either from benzene or from butene or butane. So we will see three routes. We will calculate percentage atom economy for these three routes, and then we will decide which is best for us. Okay. So first we will take example of benzene, oxidation of benzene. Now we know benzene is what, C6H6, and this is what the structure. Okay. Now see here what basic knowledge we should have, that we will discuss here. So see, now I wrote the molecular formula C6H6, but in examination you may be given with this structure. Now this is very simple structure. Okay, but sometimes the structure may be a naphthalene or maybe any other hydrocarbon where hydrogen and carbons are hidden. So you should be able to identify number of carbons and atoms. Okay, so I will draw structure of benzene and let us see how to identify atoms. Okay. So you know well benzene is this entity. First basic aromatic hydrocarbon. So here ring is given. So meaning of ring is actually 3 pi bond, alternate double bond. Okay. Now all carbons and hydrogens are hidden, but at every corner we have one carbon. So 1, 2, 3, 4, 5, 6. So I should write C6. Okay. Now what about hydrogen? Hydrogens are also hidden. So here we have carbon, and what is the valency of carbon? 4. So we have one sigma bond, this is another sigma bond, and this is pi bond. So 3 valencies are satisfied. Okay, so 4th must be hydrogen. Okay. So 4th must be hydrogen. So 1, 2, 3, and 4th must be hydrogen. Here we have one hydrogen. Similarly, we have 3 bonds. Means here one more hydrogen. 4th valence is satisfied. Okay. Here we have again 3 bonds. Means 4th must be hydrogen. Here again 3. Here again 3 bonds, and here also. So at each corner we have one hydrogen atom. Okay, so one, two, three, four, five, six. Six corners means hydrogen 6. So H must be 6. That is the way we should write. Okay, but this is just simple structure, so you can easily write. But if you have complicated structure, you should be able to judge how many carbons and hydrogen atoms are there. It's a very important case because we are talking about, you see, if you look at the formula, we are talking about molecular weight of the product. So to calculate molecular weight, you must have correct molecular formula. Then only we can calculate correct molecular weight, right? And here also total molecular weight of reactant. So you have to play a lot with molecular weight. So your formula must be correct. Now, since it is oxidation, so oxygen is involved. Then, okay. So oxidation of benzene. So we wrote benzene. Since it is oxidation, okay, I write oxygen. Then this is catalyst, B2O5. This is not reactant or reagent. This is just catalyst. Its role is to accelerate forward reaction. That's all. Then we have maleic anhydride. This is what the product. Now, just by looking at the name of the compound, we cannot write that name. Let me erase benzene. Okay. So this is what the this is maleic anhydride. So this is not IUPAC name. So we cannot judge it. So you have to keep this name in your memory also. There is no other code. This is what maleic anhydride. Okay. So if you look at this structure, this is oxidized product of benzene. So here we have benzene. This is now oxidized. Okay. In presence of this catalyst, and we have the desirable product and byproduct also. So byproduct is obviously two. This is actually CO2. Byproduct is CO2. Okay. So now question is how to balance this reaction. This is not balanced reaction. Okay. So first step is you should be able to write this one-step reaction. Reactant is benzene, then oxygen, reactant, product structure. You must know this structure. You have to keep this in your memory only, and correct structure. You should not miss any single bond, okay, or any single atom. Okay, and byproduct. So this structure you should know. Now we will balance out this reaction. How to balance out that you know well, but let us revise it. So first you look at the carbon atoms present in the product. 1, 2, 3, 4. In maleic anhydride, 4 carbon atoms are present. Okay, but in reactant we have 6 carbon atoms because it is benzene. So it means only out of 6 carbon atoms in benzene, only 4 are converted into product, desirable product. Definitely there must be 2 carbon dioxide molecules. 2 कार्बन आपल्याला जर अकोमोडेट करायचे असतील तर 2 CO2 रिलीज होतील. That is what simple logic. So I must write 2 CO2 first. Okay. Now you just count oxygen. How many oxygens are there at the product side? So here we have 1, 2, 3. 3 oxygen atom in desirable product, and 2 into 2, 4. 4 atoms in CO2. Means byproduct मध्ये 4 atom गेले ऑक्सिजनचे, and main product मध्ये 3 ऑक्सिजनचे atom. टोटल किती आले? 2 into 4 plus 3, 7. 7 atoms. So 7 atoms at the product side, product and byproduct side. So 7 atom must be provided at reactant side. Okay. So how to get it done? So we must balance out this oxygen. So 7 oxygen atoms we want. 7 oxygen atoms means how many molecules? 7 by 2 molecules. Okay. 7 by 2 molecules means what? Okay. There is one more twist in this reaction. Let me emphasize that. So see what we did, we wrote malic anhydride molecule first. Okay, problem with the keyboard. Uh, we wrote major product first, malic anhydride, that you have to keep in your memory. Okay. Then we counted number of carbon. So number of carbon 4. Okay. So in benzene there are 6. So 2 are missing. So 2 will go in byproduct CO2. Okay. But we did not count hydrogen atoms. So let us count hydrogen atoms. That is what actually important part. So if we look at this carbon, there is no hydrogen directly attached. This is linked to C double bond O, this is linked to oxygen, and this is to this carbon. So there is no hydrogen directly attached to carbon. Now let us go to neighbor carbon. Here we have 3 bonds attached to carbon. So there must be one hydrogen to satisfy 4th valency. इथे hydrogen असायलाच पाहिजे. Okay. Then if we come at this carbon, situation is same. Here there is one hydrogen. Here there is no hydrogen atom because carbon valence is balanced with oxygen atom over here. Here also oxygen atom and here again to carbon. So no hydrogen directly attached. Here also no hydrogen directly attached because valence of oxygen is 2. So there is possibility of hydrogen over here only. Here there is one hydrogen, here another hydrogen. Means total hydrogen is 2. Only 2 hydrogen atoms are utilized for formation of desirable product. But in benzene we have 6 hydrogen atoms. It means 6 minus 2 means 4 are missing. 4 hydrogen atoms are missing. So those 4 hydrogen atoms will produce water only. Definitely water, no other product. So you should write water molecules. Okay. Now 4 hydrogen atom is definitely 2 water molecules that you should be able to judge. 4 hydrogen atom means 2 water molecules. Just like 2 carbon atoms means 2 CO2, 4 hydrogen means 2 H2O. You should be able to write this way only. Malic anhydride structure 2 CO2, 2 H2. Now remaining part is what? Balancing of oxygen. Okay. So now let us count number of oxygen at product side. 1, 2, 3. 3 plus 2 into 2 means 4. किती आले? 3 आणि 4 7 झाले. 7 plus 2 means 9. So we want in all 9 hydrogen atoms at RHS means right hand side of the reaction means product and byproduct. Okay. We have desirable product and 2 byproducts. So atoms are wasted. All atoms are not there in desirable product. Byproduct produced. Okay. So total how many? Total how many oxygen we want? 9. See 3 over here in the main product. 3 plus 4 7 plus 2 9. 9 oxygen atoms. Atoms 9 पाहिजे. म्हणजे मॉलिक्यूल किती पाहिजे? 9 by 2 पाहिजे. 9 by 2 means what? 4.5. 9 by 2 is 4.5. So now this is balanced reaction. Okay. So one molecule of benzene when treated with 4.5 molecules of oxygen means 9 atoms of oxygen. Okay. In presence of B2O5 we get malic anhydride which is a major product, and along with that we have 2 CO2 and 2 H2. Okay. So here you could easily identify here reaction efficiency means atom economy. This atom economy is not 100% because all the atoms in reactant they are not converted to desirable product. They are converted to byproducts also. So atoms are wasted. So definitely atom economy is less than 100%. Okay, let us calculate actual atom economy of the reaction. So this is what the molecular structure of benzene CCH6 4.5 O2. Okay. Now if you look at malic anhydride, okay, just find out number of carbon, hydrogen and oxygen. Means I mean to say you should be able to write correct molecular formula. So let us try to write that. This is very important part. Okay. So we will give same treatment. The treatment which was given to benzene to find out number of carbon and hydrogen. We will give same treatment over here. So you just count carbon first. One carbon, second, third, fourth. So C is what? C4. No doubt. Okay. Then H. H we already calculated. Here there is no hydrogen. Here is one. Here is another. Here is no hydrogen. Here also. So only 2 hydrogen. So what I should write is H. Sorry. H2. Whatever. H2. C4 H2. And how many oxygen you could see in this molecule? One over here, this another, and this is third. So oxygen becomes. So this is what the way we should use, okay, to find out correct molecular formula. Why? After writing balanced chemical reaction. So this is what the correct formula. And we need this formula because we are interested to calculate molecular weight of the product. Okay. So that is what written over here. C4H2O3 molecular formula and 2CO2 and 2H2. So you should convert reaction in the form of this molecular formula way. Okay, this is structural way, this is molecular formula way, because we are interested in calculating molecular weight. So to find out molecular weight we must know correct molecular formula. Okay, now remaining job is very simple. We just have to use this formula, atom economy formula. What it suggests, molecular weight of the product is what? Molecular weight of maleic anhydride only, because maleic anhydride is a product. These two are byproduct. We should not consider them at numerator. Only product divided by total molecular weight of reactant. Now reactant should be all reactant, but not catalyst or solvent. Means benzene and oxygen. Only two and not B2O5. This concept should be clear. Okay, otherwise your atom economy will be wrong. So molecular weight of product means molecular weight of maleic anhydride divided by total molecular weight of reactant means molecular weight of benzene plus molecular weight of oxygen into 100. That is what atom economy. Okay, so molecular weights, we have benzene at reactant side. So C6H6. C means how much? C means 12. 12 into 6 means 72. And one hydrogen is 1. So 1 into 6 means 6. 72 plus 6 means 78. बरोबर? That you know how to find out molecular weight. और एका कार्बन ॲटमचा ॲटॉमिक वेट किती असतं? 12. अच्छा किती ॲटम आहे? 6. 12 गुणिले 6 76. हायड्रोजनचं किती असतं? 1. अच्छा किती आहे? 6. ओके, म्हणजे 6 झाले. 72 plus 6 means 78. Similarly, oxygen molecule. So one oxygen molecule means how much? One atom is 16. Okay, 16. आता किती आपल्याला atom molecule मध्ये 2. 16 into 2 means 32. Okay, oxygen is 32. That you know. And maleic anhydride C4. C4 means what? One carbon atom is 12 into 4. Okay, 48 plus 2 hydrogen atoms. 1 into 2 means 2 and 3 oxygen atoms means how much? One atom is 16 into 3 means again 48. So that is what 90. If you add them together, 12 into 4, okay, 48 plus 1 into 2 means 2, 50 plus oxygen 16 into 3 means 48. If you add them together, you will get 98. That is what the molecular weight of the product means, molecular weight of maleic anhydride. So percentage atom economy is equal to what? Molecular weight of product. In this case, molecular weight of maleic anhydride divided by total molecular weight of all reactants. Okay, not catalyst, into 100. Okay. So it becomes atom economy of this reaction is molecular weight of product is 98 upon 78 is benzene. 78 benzene plus 4.5 the total oxygen molecules we need, okay, to perform this reaction. So 4.5 into 1 molecule is 32. 1 molecule is 32. So we want 4.5 molecules according to reaction. So 4.5 into 30. So this is what the reactants, benzene and total oxygen. Okay, so into 100. So that becomes 44.14. If you look at the atom economy is very poor, less than 50%. Okay, 44.14%, because we are losing lot of atoms. Okay, during reaction, we are losing carbon and hydrogen in the form of CO2, in the form of CO2 and H2O. Okay. So this is the way we should use for calculation of atom economy. Okay. Now this second reactant. So we tried with benzene. Let us try with butene. So another reactant. Reaction is same. Means product is same. Okay. Product is same. Reaction route is same. Oxidation only. Only reactant is different. Reactant is butene instead of benzene. Okay. So butene you know well. Formula for butene. Let us first try to write that formula. That is actually required. Basic requirement to write a reaction. So when we talk about but, means there are four carbons. In means what? One double bond. So how to write that? So you should write four carbon. It is straight line. Okay. That becomes but part of this molecule. Now in, okay, in means what? There is one double bond. So you can write double bond over here or second position or third position. No matter. Let us write over here. Okay, so this is skeleton. Now remaining are hydrogen because this is hydrocarbon. Okay. Now just look at this carbon. What is valency? So original valency of carbon is 4, but only 2 is satisfied. So I must write 2 to get 4 valency satisfied. Okay. Now look at this carbon. 1, 2, and 3. 3 bonds. So fourth must be hydrogen. So valence becomes 4. Here 1 and 2. So 2 remaining. So there must be 2 hydrogen atoms. Here 1 occupied. Okay. So 3. 1 plus 3 is 4. So there must be 3 carbon. So this is what a butene. So this is the way you should write. Okay. Huh? Okay. So here we utilize 2 butene specified. Double bond position specified. Okay. So butene is 4 carbon. So therefore I wrote in this way. Okay, to write correct structure of final product, you should write butene in this way. 1, 2, 3, 4. 4 carbons. So 2 is what? It indicates position of in, means double bond. So at second position there is double bond. This is first carbon, this is second carbon. So at second carbon there is double bond. So in all 1, 2, 3, 4 carbon. Okay. So it is but and there is one in. Therefore butene. And at double bond is at second position, so 2 butene. That's all. Okay. Plus oxygen. Our reaction state is fixed. It in presence of V2O5. Catalyst is also same. These two are same. The product is same. Maleic anhydride. The structure I already told you. You have to keep the structure in your memory. Okay. Correct structure. Don't miss single atom or single bond. All should be intact. And now product and byproduct. Okay. Now if you look at the number of carbon atoms in butene, there are 4 carbon atoms. Okay. And if you look at the carbon atoms in maleic anhydride, 1, 2, 3, 4, means all 4 are utilized. No wastage of carbon atom. So no CO2 will be produced. Okay. In case of benzene, only 4 atoms are utilized. So 2 remaining out of 6. So carbon dioxide was produced in the previous case. But here, maleic anhydride and butene both contain only 4 carbon atoms. So there is no wastage. So no question of writing carbon dioxide. Now what about hydrogen? So you just count hydrogen. Here we have, I already told you, since it is 2 butene, at this carbon atom, only one valence is satisfied. So 3 is remaining. So 3 hydrogen atoms are here. Okay, 3. Here 1, 2, 3. 4 is a hydrogen. Here again 1, 2, 3. 4 is a hydrogen. And again here one more carbon. So its valency already one valence is engaged, 3 is remaining, so 3 hydrogen atoms. So here we have 3 hydrogen at this carbon, 3 over here, 1 hydrogen and another hydrogen. 3 plus 3 6 plus 2 is how many? 8. 8 hydrogens are there. at a reactant side. So let us count in a product at a product side. So in product, here there is no hydrogen, here also no hydrogen, here also no hydrogen, here one hydrogen is there. Okay, because carbon valence is 4, 3 is satisfied, 3 valencies are satisfied, one is remaining. So one hydrogen over here and another is over here. Okay, so only two are utilized in product. So definitely there is byproduct, and that byproduct is water. Okay, how many remain? See, 3 plus 3, 6 plus 2, 8. 8 are there in a reactant. Okay, in tubularity. So only 2 are utilized in a desirable product. So 8 minus 2 means 6. 6 hydrogen atoms remain. So those all 6 will go into water. Now 6 hydrogen means कितनी H2O? Obviously 3 H2O, because 3 into 2 is 6. So you should guess in this way only number of water molecules by counting hydrogen. Since we have 6 hydrogen remaining, we must write 3 H2O molecules. This is the way you should do it. Okay, don't mug it up. It's very simple. Now the question is how to balance out oxygen atom. Okay, we wrote reactant, we wrote oxygen number casually, single number. Then we will balance oxygen finally, not initially. Okay, initially we will write only skeleton. Reactant, oxygen molecule, catalyst, main product. Accordingly, we will write byproduct. So in this case, only water is possible. CO2 will not be produced because all carbons, all 4 carbons are utilized in product. So no CO2 is produced. Okay. Now, how to balance out oxygen? We just count oxygen at the product side. 1, 2, 3 in the main product and 3 in oxygen, in water molecule. 3 water molecules means 3 oxygen. So 3 plus 3 is 6. 6 oxygen atoms I want. You see, 6 oxygen atoms I want. Okay, to get this product and byproduct. So 6 oxygen must be provided. Okay, at the reactant side. So 6 oxygen atoms I want means 3 molecules. ओके 6 ऑक्सिजन आयटम कधी मिळतील ज्यावेळी 3 मॉलिक्यूल मी वापरेल म्हणून इथे मी काय लिहिलं 3O2 मॉलिक्यूल. So 3O2 molecule will give 3 into 2 6 atoms. So 3 atoms out of 3 atoms 3 will go in main product and 3 will go in water molecule in byproduct. The reaction is balanced. Now this is ready for calculation of atom economy. Okay, so next time we will see how to calculate the atom economy by calculating molecular weights of the reactant and product. Okay, so here we will stop now. So Kurtakar sir is here to continue this lecture.